Hello, this is Virgil, Labrador, Editor-in-Chief of Satellite Markets and Research, and we're here at the Amphinicy booth in Satellite 2019 in Washington, D.C. with Franny Milosh. He's the country manager for Luxembourg of Amphinicy, and we just did a video 2 months ago at CAPSAT in Dubai.
Right.
And at that time you talked about your Monica product,
Exactly.
and I understand here at the Satellite Show you're all focusing or highlighting your new product called Blink.
Exactly.
Right.
Exactly.
So, Franny, just give us a overview first of all for those who didn't see the previous video of your company and what you do, and then what this new product is that you're highlighting here at the show.
Okay. Thanks for this nice introduction, Virgil. So, actually, for all of you who still don't know us, we are Amphinicy Technologies. We are a software provider for the satellite industry. We operate already for 20 years, developing and delivering projects for big satellite operators, VSAT vendors, teleports, and so on. So whenever it comes to ground segment, we are there to deliver the right solution for your operations. We operate with 2 offices, one office in Croatia, Zagreb, this is where the headquarters is, and then we have another office in Luxembourg, also engineering office, to support the Benelux region and region of Western Europe. And we have some products in our portfolio. On CAPSAT we were promoting Monica, which is our MNC, monitor and control solution.
Right.
And this time we are presenting Blink, which is like disruptive and fully innovative and fully software-based data acquisition system for Earth observation.
Right. It's specifically for the Earth observation market.
Well, actually, it's for any kind of remote sensing, but since Earth observation requires the biggest bandwidth and higher data rates, we are targeting Earth observation. This is the best kind of pilot to show what our product
right.
does.
So this will do sensors of whole geographies and weather, temperature, that kind of thing.
The idea is that when you have typical Earth observation missions, what they do is actually they record a huge number of data in the space from the space, and then when they come above the ground station, they need to dump all this data with high speeds in 15 minutes. They need to dump like gigabytes of data.
Right.
So in order to do that, you really need to have either very high data rate, high speed demodulators, or you can have more flexible and software-based solutions like Blink, and this is where we come from.
So it's very similar to Monica in the sense that you process a lot of information that you're able to process and aggregate all those information.
Exactly. Yeah. What we actually try to do is, move to make this big move from heavy hardware-based solution, so heavy FPGA-based solution, more towards the software. So as much as possible, like all the digital signal processing, all the front-end processing is now in software. Right. So it leaves you with a software-defined radio, which has some basic functionalities like analog-digital conversion, but all the rest is in. And I'll tell you one more thing: it can be deployed in the cloud as well, because it's fully software-based. So you don't need your own infrastructure anymore, your own hardware, and so on.
Right. So that's why it's called Blink. It's an observation,
It's actually called Blink, because it can get you the data and process the data in a blink of an eye. In a blink of an eye. Yeah, exactly.
All right. So I understand you have a demo here.
We have a demo,
Okay.
and we have our technical lead engineer for Blink, Tomislav Nakic-Alfirovic, who can give you a quick tour of the solution.
Well, thank you very much, Franny.
Thank you, Virgil.
So Tomislav, what are we looking at here?
We are looking at our data acquisition system called Blink. It's built for Earth observation missions. So you have your satellite collecting data, passes over a ground station. You have the amounts of data transferred to the ground are increasing, so it's very high-speed transmission, wide channels. Blink is able to receive these. Receive the signal, run the digital signal processing, and extract the content and forward it downstream for image processing and further.
Right. Now, how is this different from other products out there?
Well, Blink is actually very different from other products because typically before Blink you had basically 2 options. You could buy a traditional modem for 100,000 euros or probably more sometimes, which is FPGA based, which is fairly rigid, limited in the complexity that it can express. FPGAs are fast, but they can't really represent a lot of complexity.
Right.
So they're notorious for being hard to use. When they fail, the outages are long, so your device is unavailable for 2 months because it goes back to the manufacturer and then returns, and so on. We're building Blink. It's heavily software based, so the entire DSP chain, the digital signal processing, and afterwards the frame and packet processing, so DVB-S2 or CCSDS, whatever the case may be. It's software based, so you can make the level of abstraction is higher, so we can express a lot more logic. We can make it richer. We can make it smarter, and it's native to the cloud.
Right.
You had software demodulators before as well, so this would be the other solution that you could use before, and they had this flexibility and declarative design and so on.
Right.
But the problem is that they were limited to a megahertz or a megabit in throughput, because signal processing is a very compute intensive kind of type of processing.
Right.
What we're doing is we're making use of current commercial off-the-shelf compute platforms and targeting hundreds of megabits per second of throughut in software. So that's kind of the best of both worlds.
Right.
That's what really sets Blink apart.
Right. Now, when was this actually launched? Is it just here at the show, or you already have clients for this product?
So no, well, for parts of Blink, we've already found clients, and the front-end processor has already been delivered for certain Earth observation missions. The front-end processor actually already works at gigabit and higher speed, so that's like the most demanding missions currently available, currently operational. We are now working on the signal processing part more, so towards the end of the year we expect to we already have working prototypes. Towards the end of the year we expect to improve speeds, widen the broaden the types of missions supported, protocols supported, and so on. So it's a bit early days, but it's the right time to talk about it with customers, and we've seen significant interest. So it's basically a confirmation of what we've heard before, and a confirmation that we're heading in the right direction. It's a matter of getting it done.
Right. And you can customize it for a client?
Yes, we can. Every mission is specific in one way or another, and therein lies one of the strengths of a software-based solution. Because software, you can it's an order of magnitude faster to customize than hardware or even an FPGA-based design, and that's where we're gonna really disrupt the market. So the time we'll need to adjust the system for a new mission, it's gonna be unprecedented. So if you look at the front-end processor, we're already, so we get a data sample for a new mission. We can often in a couple of days provide the first results of streaming this data through our parser. For the DSP, it may not be a couple of days, depending on the mission, on the types of processing. So telecommunications is a very broad area. So, but it's definitely, by the nature of it, going to be much faster than what's currently possible.
Right. Well, thank you very much, Tomislav.
It was a pleasure. Thank you for talking.
Thank you.